Rachana.
Hello, students. I hope you hear me. So today we are going to start a new chapter, that is permutations and combinations. Permutations and combinations. First, I will give you the list of formulas, definitions, everything related to this chapter. Some shortcut methods also. Quickly, we will review what is permutations and combinations. Anyways, we have 4 days for this chapter. So in these 4 days, we can learn a lot. I'm putting the list of formulas. Here it is. First of all, what is permutations? Permutations means arrangements. Arrangement of some things or all the things which we have. We can take a few things or we can take all the things. Next comes, what is linear permutation? Linear permutations means when we are arranging in a line. That comes under linear permutation. Now, circular permutation means if we are arranging in circle, a closed curve, that is circular permutation. So when you are arranging things, suppose total you have n things and you are taking only r things. You are not taking all the things. You are taking only r things out of n things. And then you are taking linear permutation. You are arranging in a line. Then in how many ways you can arrange? The number of arrangements, the number of ways is NPR, or it can be written like this, or it can be written like this. Total, you have n things. Out of n things, you are taking only r things and arranging them in a line. In how many ways you can arrange? That is written as NPR. Now, if you take the number of permutations of n things, taking r at a time, it is same as filling r places by n things. Suppose total you have n things. You are taking r things and arranging. That means you have r places, r blanks, rth blank, first space, second space, third space, like that, rth space, rth blank. So these are things in how many ways you can take and in how many ways you can arrange. That is only number of permutations. So how to find number of permutations? Before going to that, we will learn something called fundamental counting principle. What is this fundamental counting principle? If one work can be done in m ways and a second work can be done in n ways, then the two works together, one after the other. Succession means one after the other. First work, then second work, one after the other, can be done in m into n ways. For example, I can read books in 3 ways. Reading I can do in 3 ways. After that, second work, writing I can do in 5 ways. Then both reading and writing, first reading, then writing, I can do in 3 into 5. That is 15 ways. This is what fundamental theorem of calculus or fundamental counting principle. Fundamental counting principle will tell you. Suppose instead of 2 works, reading and writing, here I'm talking about only 2 works. But if there are k number of works, k works are there. The first work can be done in first work in n1 ways, second work in n2 ways, third work in n3 ways, like that. Kth work in nk ways. Kth work in nk ways. Then the total work can be done in n1 into n2 into n3 into nk ways. That is the meaning. So this fundamental counting principle is not only for 2 works, it is for more than 2 works also. For example, you can wear shirt. You can wear shirt in 2 ways. You can wear trousers in 3 ways. Like you can select the trouser. You can take the trouser. How many trousers are there? That you can wear in 3 ways. After that, socks. You can take the socks and wear in 5 ways. Then the total work, wearing shirt, trousers and socks, 2 into 3 into 5. That is 30 ways. So here you are doing 3 works. Like that you can do 10 number of works. You can do 100 number of works. But the fundamental counting principle will be this only. Multiplying the number of ways each work can be done. So the same is for NPR also. Sagar, mute your mic. Okay. NPR also the same principle, fundamental counting principle only. Just now I told you, total you have. I will erase this because I don't have space. NPR, total you have n things. Out of n things, you are taking r things and you are arranging in r places. Rth place. In r places. So in how many ways the first place can be filled? In n ways, because total n things are there. Second place, 1 is already filled. So the second place can be filled in n minus 1 ways. So this is also filled. The third, 2 already you have taken and filled. So the third place, n minus 2, 3 are filled. So the fourth place, n minus 3 ways. Like this, if you see each and every work, total you have to do R number of works. First work in n ways, second work in n minus 1, n minus 2, n minus 3, rth work. Total R works are there. So these can be done in n into n minus 1 into n minus 2 into n minus 3, like that. N minus, for rth place, r minus 1. That is how you got. Anyways, this you have learned in PU, so I'm not explaining that much. NPR can be written as n into n minus 1 into n minus 2 up to n minus r plus 1 base. So this is the basic formula for NPR. Later on, the formula is improved. First, we will learn about factorial n. Factorial n is written like this or like this. What is factorial n? 0 factorial is 1. If you have 0 factorial, it is 1. 1 factorial is also 1. 2 factorial means start with 2, subtract 1. So you will have 1. Then you can put factorial, or that's it. You can stop here. 2 factorial means 2 into 1. If you have 3 factorial, start with 3. 3 minus 1, 2. 2 minus 1, 1. You can stop here. This is 3 factorial. 4 factorial. Start with 4. 4 minus 1 is 3. 3 minus 1 is 2. 2 minus 1 is 1. You can stop here. Like that, any factorial you can write. Now, n factorial, you can write n into n minus 1 factorial. See, suppose if I have 7 factorial, I can write 7, 7 minus 1, 6, 6 minus 1, 5, 5 minus 1, 4, 4 minus 1, 3, 3 minus 1, 2, 2 minus 1, 1. Or you can write 7 and all these you can write it as 6 factorial. Or you can write 7, 6 and then all these you can write 5 factorial. Suppose if you want to write 7, 6, 5, 4 and you want to stop, you can put factorial and stop here. Wherever you want to stop, you can put factorial and stop. Suppose if I give you n factorial, you'll start with n. Next is from n, subtract 1. If you want to stop here, you can put factorial and stop. Otherwise, n, from n minus 1, from n minus 2, stop here, put factorial. Otherwise, n, n minus 1, n minus 2, n minus 3, stop here by putting fact. Wherever you want, you can stop by putting factorial. So this is the meaning of factorial. Let me remove all these. Okay. Now, n factorial means 1 into 2 into 3 into 4 into 5 up to n. That is n factorial. Or you can write n factorial like this also. Start with n minus 1, again minus 1, again minus 1. Like that, go on subtracting 1. One fine day, you will reach, if you go on minus 1, you'll reach 3, minus 1, 2, minus 1, 1. Like this also you can write n factorial. 2 ways. Now the exact definition of NPR is n factorial by n minus r factorial. Suppose if I give you 7p2. So it will be 7 factorial by 7 minus 2 factorial. Or 7 factorial by 5 factorial. Or Start with 7, minus 1, stop here, put factorial and down 5 factorial, so that 5 factorial and 5 factorial will cancel. So this is how you will use this formula. Now, if you have total n things and you are taking all the things, then the number of arrangements, the number of permutations is npn, that is n factorial. You are not taking only r things, you are taking all the n things and arranging. Then there is one formula for NPR, that is n minus 1 PR plus R into n minus 1 PR minus 1. What does this mean? You can take one example if you want to understand. Suppose if you have 6P4, you can write 6 minus 1, 5, P4 plus 4 into 6 minus 1, 5, P, 4 minus 1, 3. Like this also you can write using this formula. Next, the number of one-to-one functions from a set containing R elements to a set containing N elements is NPR. One-one functions we are seeing. All these are shortcut methods you have to remember. The number of bijections, that means 1, 1 and onto both, from a set containing n elements onto a certain containing n elements is n factorial. So how many 1, 1 and onto functions? How many 1, 1 functions? Using this formula, you can make it. Next, the number of permutations of n things taken R at a time when repetition is allowed, that will be n power R. So what is meant by repetition is allowed, repetition is not allowed? For that, I have to explain to you with an example. For example, I'm giving you 3 letters A, B, C. I will ask you, take any 2 letters at a time. Take only 2 letters, 2 blanks, 2 places you have to fill up. So what I will do? I will take AB, BC, CA. Or I can write BA, CB, AC. In all these arrangements, repetition is not allowed. Why repetition is not allowed? See, once A came, it is not coming again. Once B came, it is not coming again. Once C is there, another C is not there, A is there. So in such cases, repetition is not allowed. In such arrangements, repetition not allowed. Then the formula will be total 3 things, taking 2 at a time. The number of arrangements, that is n factorial by n minus r factorial. That is 3 factorial by 1 factorial. That is 6 ways. You can see I have written 6 ways here. 6 ways of arrangement are there. the number of permutations is 6. But suppose if repetition is allowed, suppose the same case A, B, C, you have to take two things and arrange. So that will be AB or BC or CA or BA, CB, AC. Now if I say repetition is allowed, suppose if repetition is allowed, so I'm writing here repetition is allowed. Then I will add 3 more cases. What are the 3 different ways? I can take A only 2 times. I can take B only 2 times. I can take C only 2 times. This is repetition allowed. Then what is happening? Total 3 things. I'm taking 2 things and repetition is allowed. So the number of permutations will be 3 square. That is total 9 ways are there. So this is the formula 3 square. This is the formula they said. In 16th point n power r. Coming to 15th. Suppose if I give you A, B, C, 3 things, and I'll ask you to take all the 3 things and arrange. In how many ways you can arrange? First, you will take A, B, C and arrange like this. Otherwise, you will write A same. You will arrange B, C as CB. Otherwise, first I will take B, A, C, I'll arrange. Or instead of B, A, C, easy method, I will take B, C, A and arrange. So keeping B same, C, A, I'll arrange it as B, A, C. So 2 more ways. Now I'll take C first, then AB. Keeping C as it is, I can arrange AB as BA. So total 6 ways I can arrange. That means total 3 things. I'm taking 3 things. I'm taking all the 3 things. So that can be arranged in 3 factorial. That is 3 into 2 into 1. That is 6 ways. This is only 15th formula. N factorial. I took 3 factorial. I'll put the next set of questions. I mean, the next points, important points. The next is the number of permutations of n things taken not more than r at a time. Not more than r means what? I can take 1 thing, I can take 2 things, 3 things, 4 things and arrange. But I can take only R things. I can't take more than R. So when such things happen, I am counting all. Permutation by taking only 1 thing, arrangements by taking only 2 things, arrangements by taking 3 things. I am counting all. Arpita, mute your mic. Arpita, mute your mic. Okay. So you are taking one thing and arranging, two things and arranging, three things. I'm taking all sort of arrangements. Then the number of permutations will be n into n power r minus 1 by n minus 1. This is also shortcut form. Same way, the number of functions from a set containing r elements into a set containing n elements is n power r. So here we are talking about number of functions you are making. There is a set. In this set, r elements are there. In this set, n elements are there. You are making a function that you can make in n power r ways. Let's go to the next set of formulas. I'm putting it down. The number of permutations of n things taken all when p of them are alike and the rest all are different is n factorial by p factorial. So till now, whatever permutations we were talking about, in that what happened is n different things are there, r different things, n are different, r also different. But now the case is total you have n things. Total n things. And out of that, there are p things which are same. They look same exactly. And the remaining n minus p things look different. Then in how many ways you can arrange? That is n factorial by p factorial. Suppose I will give you one example for this. I will give you a word. And that word is sister. In sister, there are alphabets. S, I, S, T, E, R. So total N, how many letters are there? 6 letters. Out of that, R, how many letters are repeating? Can you tell? How many letters are same? How many letters are looking alike? S and S looking same. 2 letters are same. So if you want to arrange these 6 letters, that can be done in total 6 permutations of 6 things. But here the formula will be different. What it will be? N factorial by R factorial. Because 2 things are same, so down I'm writing 2 factorial. N factorial by P factorial. You can take P or R or anything. So what will be this? Six into 5 into 4 into 3 into 2. Put 2 factorial and stop. So 6 5 is 30, 30 12 is 360 ways. That's the answer. Okay, next. Next one is similar to this. There are P1 things looking alike, P2 things alike, P3 things alike. Like that, PK things are alike. And then total you have P1 plus P2 plus so on up to PK. Total, this many things you have. So what will be the number of permutations? In numerator, P1 plus P2 plus P3 up to Pk factorial, n factorial. Total n things are there when you add up. And down, P1 factorial, P2 factorial, Pk factorial. They are looking alike. P1 things are alike, P2 things are alike, P3 things are alike. Different kinds. So this is the formula. Next, already we have talked about circular permutation. If total you have n things, you are taking r at a time, the circular permutation will be npr by r. You are arranging things in a circle. Next, the number of circular permutations of n things, taking all, it is n minus 1 factorial. If you take all the n things, it is very good. It is n minus 1 factorial. Next is number of circular permutations of n things taken r at a time in one direction. It is npr by 2r. The number of circular permutations of n things taken all in one direction is 1 by 2 into n minus 1 factorial. So actually, these two are similar. These two are similar, but not exactly same. Because here, when you are seeing circular permutation, you can see in this direction as well as this direction. You can count the arrangements. Whereas in the second one, they said circular permutation in one direction. That means only in this direction. So that is the difference. See, the formulas are same. Here NPR by R, here also NPR by R. In denominator, 2 is there, 1/2 or 2. Then see these two formulas, n minus 1 factorial, n minus 1 factorial by 2. That's the difference. When it is in two directions, denominator you don't have 2. When it is in one direction, denominator is 2 because you are halving. Total number, you are making half of it. Total number of permutations, one direction means you are making half of the answer. Then some formulas are already written here. NPR plus R into NPR minus 1 is N plus 1 PR. NPR by n minus 1 PR minus 1 is n. NPR by NPR minus 1 is n minus r plus 1. Next, if n is a positive integer, p is a prime number, the exponent of p is n factorial is n by p plus n by p square plus n by p cube, where x denotes the greatest. Actually, this formula we will leave it because you did not study greatest integer function. When you study that, I will explain again. The next formula is the number of ways in which m things of one type, n things of another type can be arranged in a row so that no two things of the second kind come together. That will be m factorial into m plus 1 pn. For this, I will give you example. Suppose there are m things of one kind. That means boys. Boys, there are 9 boys. Suppose there are n things of one kind. That means there are girls. And I will take n as 7. M is the number of boys, n is the number of girls. Now, if I want to arrange in a row, boys and girls should not come together. No two things of the second kind come together. Or no two things of the first kind come together. There are many ways. Boys and girls should not come together. Boys should not come together. Girls should not come together. Suppose if they say second kind, that is no two girls can sit together. Girls should not be side by side. No two girls. No two girls means what? No 3 girls, no 4 girls, no 5 girls, no 6 girls, no 7 girls should sit together. So then how many ways will be there? For boys, no condition. 9 boys, wherever you want, you can make them sit. So first m factorial. For girls only, there is condition. What is that condition? M plus 1, 9 plus 1, 10, P, N. N is 7. Girls can be arranged in this ways because no two girls can sit together. Now, why this is happening? There is examples, there is explanation in PU book. Now, this is just shortcut formula which we are learning. Let me put some more formulas along with shortcut formulas. Many are there. Here, the number of ways in which m things of first kind, n things of another kind has to be arranged in a row in such a way that second type of things come together. This time, second type should come together. Then in how many ways you can arrange? The same example I will take. First M I will take 9 boys. Then N I will take 7 girls. Total 9 plus 7, 16 students are there. You have to arrange them. But second type of things come together. That means 7 girls should sit together. All the 7 girls should sit together. You have to tie up all the 7 girls and tie them up with a rope and make them sit together. So that can be done in n factorial, 7 factorial, and m plus 1, 10 factorial. This is how you have to take examples and remember it. Next, the number of ways in which n things of first type, they are different, but first type. N things of second type can be arranged in 2 into n factorial into n factorial ways. What do you mean by this? There are n things, like 5 boys are there. There are boys, they are boys only. But all these 5 boys are not same. Their faces, their eyes, their nose, everything will not be same. These 5 boys are different types. And there are n things. That is 5 girls are there. They all look different, but the type girls make them same. There are girls, but they are not same girls, different girls. If you want to arrange them in a row, 2 into n factorial into n factorial. This is what happens. Okay. Next. Sum of numbers formed by taking all the n digits excluding 0 is the sum of all digits into n minus 1 factorial into 1, 1, 1, 1, 1. You will write n times. So I'm not including 0. Suppose I will give you 0, 1, 2, 3. Okay, 4 also. So here 0 is excluded. Now I have only 1, 2, 3, 4. Now I will make as many numbers as possible with these 4 numbers. And after that, I have to find the sum of all. Sum of all the numbers which I made. So what will be the answer? First, you have to add up all the numbers. 1 plus 2 plus 3 plus 4. Then you have to multiply. Total n means 4 numbers are there. So n minus 1, 4 minus 1, 3 factorial into this 1, 1, 1. I have to write n times. 4 times I have to write the 1. This is how I will make as many numbers as possible, and I will add those numbers also. Next, sum of the numbers formed by taking all given n digits including 0. This time I am including 0. Then the sum will be sum of all the n digits. Then n minus 1 factorial into 1, 1, 1, 1 n times minus n minus 2 factorial into 1, 1, 1, 1 n minus 1. What is the second case now? I'm including 0, 1, 2, 3, 4. Total 5 numbers I have. When I arrange these numbers and add them all, First, I have to take sum of all the numbers which I have. And then I have to multiply with n minus 1, 5 minus 1, 4 factorial into 1, 1, 1, up to 5 times I have to write. N is 5. So I will write 5 times. This is the sum of all the numbers including 0. But then to this I have to add n minus 2, 5 minus 2, 3 factorial, and 1, 1, 1, I have to write n minus 1. That is 4 times I have to write. 4 times I have to write. Here 5 times I have to write 1. Here 4 times I have to write. This is the total sum. Next, sum of r digit numbers formed by taking n digits without 0 is sum of all the n digits n minus 1 pr minus 1 and 1, 1, 1 r times. Now, I'll give you 0, 1, 2, 3, 4. But 0 is not to be taken without 0. I'm taking r digits. Like I'm taking 3-digit numbers. As many 3-digit numbers I will form, that would be better. So make the 3-digit numbers and after that add them. Sum of 3-digit numbers. This is without 0. So what I will do, first I will take sum of all the n digits. What is n? N is 4. 1 plus 2 plus 3 plus 4. Then n minus 1, 4 minus 1, 3. P, r minus 1, 3 minus 1, 2. And 1, 2, 3. I will take 1 how many times? R times. So R is 3. Only 3 times I will take 1. Because R is 3. This is how the formula I can get an answer I can get. All these look confusing, but the thing you have to practice. If you practice, they will look easy. Take some examples. Sum of r digit numbers formed by taking from n digits, including 0. This time 0 is included. Then sum of all the n digits. N minus 1 p r minus 1 is multiplied with 1, 1, 1, 1 r times. Minus n p2 r minus 2. Now you will have 1, 1, 1 only up to r minus times. So I'll give you one example for this. What is this example? Suppose I will give you, including 0, 0, 1, 2, 3, 4, I will give. So n is 5 here. 0 is also included. N is 5. So how many numbers I can form, and after forming, if I add, what will be the sum? So first I have to take sum of all the digits I have. Then I will multiply with n minus 1, 5 minus 1, p, r minus 1. What is r? What is r? You are taking only 3 digits. So r is 3. You are making only 3-digit numbers. Sum of all 3-digit numbers. But I gave you 5 numbers. I'm not taking all 5. I'm taking only 3. So I will add up all the 5 numbers which are given. Then I'll take n minus 1, 5 minus 1, p, r minus 1, 3 minus 1 is 2. Then I will multiply with 1, 1, 1. R times, only 3 times. Then minus n minus 2. 5 minus 2 is 3. P. R minus 2. R is 3. 3 minus 2 is 1. And then I have R minus 1 times. That is 3 minus 1 times. I have to write 2. 2 times. I have to write 1. 3 minus 1 times. R minus 1 times. That is 3 minus 1. 2 times I have to write. This is how different examples are there. This is not that easy to understand. Practice more and more problems on this. 2 more formulas are there in permutations. Rather, I will take 3 formulas. And then we will go to combinations. After finishing this permutations problems, we will go to combinations. Sorry, someone was there. So these are the next type of formulas. Number of ways in which M thinks of the first type, N thinks of the second type. M is greater than N, remember. They are arranged in a circle. No 2 things of the second kind come together. That will be M minus 1 factorial into MPN. Next, number of ways in which M thinks of first type, N thinks of second type are arranged in a circle. So all the second type of things come together is M factorial, N factorial. The third one is the number of ways in which M thinks of first type, N things of second type are arranged in the form of a garland. All the second type of things come together is M factorial, N factorial by 2. Half of this. These all come under circular permutations. Now I am not explaining much about this, but when we come to formulas, I will explain. When we come to do questions, all these formulas, I will explain. The next is combinations. Let us do some combination formulas also. Till now, permutations. What is combination? Selection, not arranging, just picking up, just selection. That is combination. How will you make a combination? A combination is made by taking R things, by picking up R things from N things. Total N things are there. From N things, you will pick up R things. You will select R things. You will not bother about arranging and on. Just picking up, throwing. Selecting, keeping it there. That's all. No arranging. So when you are taking like this from a set A, then you are making subset of it. I'll tell you, for example, in the set A, I will give you 1, 2, 3, 4, 5. Combination means, suppose I have to select three things. Just pick up three numbers. Which three numbers you are going to pick? I'll pick 2, 3 and 5. So these three numbers which I have picked up, this is subset of A. Suppose if I pick up 1, 2 and 4, that also will be subset of A. Suppose if I pick up 1, 3 and 5, that also will be subset. Whatever I pick up, whatever combination is there, that is subset of it. That is what they are saying in 38 point. Now 39, the number of combinations of n things taking R is the number of R subsets, R element subsets of a set containing L elements. What is the meaning of this? Suppose there are n things. 5 things are there total. You are taking 3 things and you are picking up. So the subsets which you are getting, the combinations, these all are combinations. Combinations means what? Subset. The subsets which you are getting, they consist of R elements. They consist of 3 elements, R elements, 3 elements. And if you count all such subsets, count the subsets formed, many subsets will be formed. Count all these subsets. That only will be the total number of combinations. If you count the number of subsets formed. And the number of combinations of n things taken R at a time is written as NCR or CN comma R or like this or like this. So here in this example, total 5 things, number of combinations by taking 3 things, selecting 3 things, 5C3. This is how I will write about combinations. In short, instead of telling in sentences. Now, what is the formula for NCR like you had for NPR? N factorial by R factorial into N minus R factorial. For NPR, it is only N factorial by N minus R factorial. But for NCR, this R factorial is also there. That's why what you can say, NCR will be NPR by R factorial. This NPR, if you divide by R factorial, you will get NCR. That is what they are saying. And already I gave you one formula for NPR. Basic formula. N into N minus 1 into N minus 2 into N minus R plus 1. This is NPR. R factorial is 1, 2, 3, 4, 5 up to R. So this is basic formula for NCR. You can use this formula or you can use this formula. So today I'm not giving any questions as homework, but whatever problems or whatever points you have learned, important formulas, learn them. Then only you will understand the next day lesson when we do the sums. If possible, you take your own sums and practice these formulas. Any number you can take. Suppose if you want 5C3, take 5C3, use this formula, 5 factorial by 3 factorial, 5 minus 3 factorial. Practice like this. See you tomorrow. We'll continue the formulas and we'll practice some problems also.